Hi, this is Algebra 1, Module 6, Lesson 5, The Tortoise and the Hare. Children's story of the tortoise and the hare. The hare mocks the tortoise for being slow. The tortoise replies, "Slow and steady wins the race." The hare says, "We'll just see about that," and challenges the tortoise to a race. The distance from the starting line of the hare is given by the function distance equals t squared, d in meters, t in seconds. Because the hare is so confident that he can beat the tortoise, he gives the tortoise a 1 meter head start. The distance from the starting line of the tortoise includes the head start is given by the function d equals 2 to the t meters and in t seconds. So, what time does the hare catch up to the tortoise? Well, let's make a table and then let's do a graph. So let's start with, we have the hare. I'm just going to put t to the second power. And then we're going to have 2 to the t power. Okay, so at 0, t to the 0 is, oh, you know what? Let's space this out. We need to have that is t. Okay, so when our time is 0, the hare is at 0. Oh my goodness, 0. And the tortoise is at 1, right? He gives him a 1 meter head start. At 1, 1 to the second power is 1, and 2 to the first is 2. At 2, 2 to the second power is 4. 2 to the second power is 4. Look at that. 3. 3 to the second power is 9. 2 to the third power is 8. 2, 1, we'll go to 5. 4 squared is 16. 2 to the fourth is 16. And 5 squared is 25. 2 to the fifth power is 32. So we've got some interesting stuff going on here. We notice that we've got a few spots where they match. Um, so in looking at this, what time does the hare catch up to the tortoise? Well, it looks like at 2 seconds, right? At 2 seconds. If the race course is very long, who wins, the tortoise or the hare? Well, if we look at this one, it looks like the tortoise is going to get bigger. Let's go ahead and do our graph. And we know we were going up to 40 over there. So our distance, let's go ahead and just go up a little bit higher. Let's go up. So we had 1, 2, 3, 4, 5, 6. We'll just go up to 7 here. Spread out a little bit. And then if we go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, if I want to get up to say like 60 or 70, I really need to count by 5. So if this is, no, I don't have to do this one. These can go by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay, so we had our first one was t squared, right? That was the hare. The hare was t squared. So 1 squared was 1, something down here. 2 squared was 4. 3 squared is 9. 4 squared is 16, so a little above 15. 5 squared is 25. Oh, that's right on a point. That's nice. 6 squared is 36. Under there. 7 squared is 49. That's up here. We could almost do 8, couldn't we? Go here to 8. 8 squared is 64. So we could get up to this, a little above 60 in there. Okay, and so then our tortoise, he was 2 to the t power. So 2 to the first, 2 to the 0 is 1. 2 to the first is 2, a little above him. 2 to the second is 4, so that one was the same, right? 2 to the third power is 8, it's a little less. Probably should have zoomed in a little bit more, huh? 4, 2 to the fourth is 16, that one was the same. 2 to the fifth is 32, though. 2 to the sixth would be 64. Look at that dude. He shot right up, didn't he? So he's under, same, boom. He got quicker, faster. So it looks like in the long run, there's this one little spot down here, basically between 2 and 4, where the hare is ahead of the tortoise, but otherwise the tortoise is ahead on all the rest of them. So if the race course is very long, who's going to win? The tortoise is going to win. What times are they tied? We'll look over here on our table and we can see at 2 seconds and seconds. All right, if the race course were 15 meters long, who would win? Well, let's look back at our thing here. If we go back to our graph, if I can zoom in a little bit, oh, look at that. So if it's 15 meters, look at right here, you can see that the hare actually gets there slightly before the tortoise. They're both at 16 at 4 seconds, but between 3 and 4, the hare is actually going faster. So if the race course were 15 meters long, come on, the text box, the hare would win because it reaches 15 meters a hare slightly before the tortoise. Our graph. All right. So use the properties of 2 to the second power and t to the second power to explain the speeds of the tortoise and the hare in the following intervals. Well, if we look at the average speed for this one, average speed is, let's see, from 0 to 2, it's going 4 minus 1, and it's doing it, yeah, 0 to the 0. Yeah, so it's not going very fast. So the average speed is 4 minus 1 over span of 2 seconds, which means it's going about 1.5 meters per second. So it's not, oh wait, the tortoise. What am I doing? Tortoise, yeah, okay, 4 minus 1 right here. So 4 minus 1, there we go, 2 minus 0, I had them backwards. All right, so then the t squared then is the average speed is 4 minus 0, because it goes 4 meters during that time, divided by the 2 seconds, equals 2 meters per second. So this one, the hair is actually going faster. So if we were to be a little more specific here, this is an exponential function, right? Because it's 2 to a variable power. So this exponential function is growing slower at this interval. And here, quadratic function, since it's to the second power, is growing a little faster than the exponential at this point. So just from that little interval, it's growing faster. Okay, so what about from 2 to 4? So the tortoise, 2 to the t, from 2 to 4 is going 16 minus 4 in those 2 seconds, right? So average speed is, this time it's 16 minus 4 divided by 2. So that's 12 divided by 2. So that's 6 meters per second. And then the hare, see, 16 to 4. Okay, so it's actually the same speed is they're going from 4 meters to 16 meters in that 2 seconds. So it's 6 meters per second as well. So what we can kind of deduct from here is the speed of the hare is growing at a constant rate, right? Because it went from 2 meters per second to 6 meters per second. This one went from 1.5 to 6, not as much of a connection there. So the average speeds are the same in this interval. Even though the exponential is growing at a faster than the quadratic. Because it's a bigger jump from 1.5 meters per second to 6 meters per second than it is from 2 to 6. So it's growing faster, but right now for that specific interval, it's the same. Okay. Now if we go from 4 to infinity, well, how are we going to do this? Well, we don't have an average speed because we're going to infinity, but the speed of the tortoise continues to grow at continues to grow, making the graph shoot up. Right? Because when we go back to our, oh, I lost it up there. There we are. We go back to this and zoom back out. Notice how that tortoise just goes even steeper, faster than that hare over here. And so the hare speed of the hair is increasing at its at a constant rate, making the curve not quite as steep. Because remember, its slope is really a linear equation, so it's constantly getting bigger, but it's not as fast as our exponential on there. All right, that's it for today. Thanks for joining us. We'll see you next time.